All right, so when you picture the tech that powers something as huge as ChatGPT, you're probably thinking, I don't know, a massive, super complex web of futuristic databases, right? But what if I told you the real story is actually way simpler, a lot more disciplined, and honestly, way more surprising than you'd ever guess? Let's dive in and unpack the real architecture behind one of the biggest AI platforms on the planet.
Okay, first things first, let's just wrap our heads around the sheer scale we're talking about here. 800 million users. That is more than double the entire population of the United States. It's a number that doesn't just, test a technical system. It's actively trying to break it, 24/7.
So here's the million-dollar question, right? For any engineer or tech nerd out there. To handle all that core data, we're talking user info, conversations, API keys, the whole shebang. For a service that massive, how many primary databases do you think you'd need? 10? Maybe 100? A globally distributed sharded cluster where data is broken up into tiny pieces all over the world? Go on, take a guess. The answer is 1. That's it. Just 1. Seriously, all the data, writes for 800 million users, go through a single primary database. And no, that's not a typo. That single decision, right there, it just completely blows up everything we thought we knew about building for massive hyperscale.
So how on earth do they pull this off? Well, that brings us to their brilliant and totally counterintuitive architecture. It is an absolute masterclass in choosing to optimize what you have over just re-architecting everything. And this slide? This shows the fork in the road perfectly. On the left, you've got the path most companies would have taken like years ago. You shard the database, you migrate to some trendy distributed system, but OpenAI, they took the path on the right. They decided to stick with a single primary, surround it with about 50 read replicas, which are basically copycat databases that handle queries, and then just optimize it relentlessly. And here are the results of that decision. It's kind of wild. They're running a single PostgreSQL server for every single write, and it's handling millions of queries a second. But look at these performance numbers. 5 nines availability. That means the system is down for less than 6 minutes a year. And the latency, the delay you feel, we're talking low double-digit milliseconds. That's literally faster than you can blink. These are elite numbers for any architecture, let alone this one.
So the secret sauce, how did they do it? It's not magic. It's just deep, smart engineering. See, they didn't try to run away from their database's limitations. They leaned in and embraced them. For PostgreSQL at this kind of scale, the biggest challenge, the real crux of the problem, comes down to a super specific technical detail, the way it fundamentally handles updates to your data. And that detail is a feature called multi-version concurrency control, or MVCC. Now, to put it simply, when you update a piece of data, Postgres doesn't just overwrite the old stuff. It makes a whole new copy. Now, this is fantastic for preventing conflicts between users, but it can lead to something called write amplification, where one tiny change ends up creating a whole lot of new data, and that can really slow things down. This was the beast that OpenAI had to tame.
And this right here, this is the key insight. Instead of looking at this feature as some kind of fatal flaw, the OpenAI team saw it as a constraint, something to be engineered around. They made the choice to work with the database's nature, not fight against it.
So, okay, how does that philosophy actually translate into action? Let's crack open OpenAI's optimization playbook and take a look.
Their success isn't down to some single silver bullet. No, it's a multi-layered defense. They use aggressive caching and rate limiting. They isolate different jobs so a brand new feature can't accidentally take down the whole service. They go in and painstakingly review the SQL code that their developer tools spin out automatically. And, holding all of this together is an incredibly strict, hardcore operational discipline.
To really get how effective this is, let's just zoom in on the impact of one of these tactics. It's something called connection pooling.
This chart really says it all. Before they implemented connection pooling, just opening a connection to the database took 50 milliseconds. After they flipped the switch, it dropped to just 5 milliseconds. That is a tenfold improvement on something that happens millions and millions of times a day. Little wins like this add up to absolutely massive gains for the whole platform. But it's not just about adding new tricks. It's also about preventing problems from ever happening. This quote is such a powerful cautionary tale. A single automatically generated query, one that was inefficiently joining 12 tables, caused major outages. It's a perfect example of why you just can't blindly trust your tools when you're working at this scale. You have to get in there and meticulously inspect what's happening under the hood.
All right, let's zoom out and look at the bigger picture. What are the strategic lessons that we can all learn from OpenAI's journey about how to scale smart, not just big?
This quote is really the core philosophy of this whole story. You should make your big technical decisions based on how your system actually works, on its real patterns and constraints, not because you're in a scale panic or just chasing the latest, coolest technology. It's all about pragmatism over trends.
So, what are the real takeaways here? Okay, first, find your actual bottlenecks before you do anything else. Second, squeeze every last drop of performance out of the technology you already know and trust before you even think about ripping it out. And if you do have to move something, do it selectively and very, very deliberately. And finally, none of it works without ironclad, strict operational discipline. That part is just not optional.
And really, this is the most important lesson of all. The point isn't for everyone to run out and try to run their company on a single PostgreSQL server. No way. The real goal is to copy their thinking, that disciplined, evidence-based, optimization-first mindset.
Which kind of leaves us with one last question to think about. The next time you're facing a massive scaling challenge, you should ask yourself, is this really a technical problem that needs a new tool, or is it a cultural problem that just needs a new way of thinking?